Hello everyone, welcome to I Plus Education. This is Sayyid Ismail. In this video lecture, I am going to discuss differential equation that are homogeneous in nature. We can say that homogeneous differential equation. Let us define what is homogeneous function first. Here we have homogeneous function. Any function f of x comma y is said to be homogeneous in x comma y of degree n if it satisfies this condition, that is f of kx comma ky is equals to k power of n into f of x comma y, where n is a constant and it is a degree of this function f of x comma y. This is the definition of homogeneous function. This is the condition by which we can verify that whether a function is homogeneous or not. Now let us see homogeneous differential equation. Here f of x comma y and g of x comma y are two homogeneous functions of same degree. F of x comma y, g of x comma y are homogeneous function of same degree. Then differential equation will be dy by dx is equals to f of x comma y upon g of x comma y is called homogeneous differential equation because these two functions are homogeneous and here we have differential. So this will become differential homogeneous equation. And one of the important thing is each term of f and g, that is f function and g function, this f of x comma y and g of x comma y should be of same degree. It means that each term of f comma g function should be of same degree. Now that is dy by dx equal to y square minus x square by 2xy. This is the example of differential equation. Now let us discuss the working rule for this. Working rule for differential equation dy by dx equal to f of x comma y upon g of x comma y. Here we have dy by dx. For this we have step 1 is substitute y equal to vx. Here v is a function of x. This v is a function of x. Now differentiate with respect to x this y equal to vx. So here I will get dy by dx. Here apply product rule, that is u into v rule. Leave the first function, differentiate the second one, plus leaving the second function, differentiating the first function. So d by dx of x is 1, so v into 1 is v, plus x dv by dx. This is the helpful equation. From this we will convert this into variable subvariable form. So the next step is reducing to the variable subvariable form. We have to convert this equation to variable subvariable form. Now the working rule for dx by dy. Here we have dy by dx, here we have dx by dy, that is reciprocal. Now for this the step 1 is substituting x equal to vy. Here v is a function of y. Here we have v is a function of x. Here v is a function of y. Now differentiate with respect to y. Here I will get dx by dy. Applying product rule we will get v into d by dy of y plus y into d by dy of v. So d by dy of y is 1, so we will get v here plus y dv by dx. Now reduce this equation to variable subvariable form and apply the concept of variable subvariable form. So in this way we will solve homogeneous differential equation. Now let us see the solution of this homogeneous differential equation. Here we have solved the differential equation 2xy plus x square dy is equals to 3y square plus 2xy into dx. Let me write down the given equation. We have 2xy. Here we have x power of 1, y power of 1, that is degree is 2, plus x square means degree is 2 into dy is equals to 3y square, degree is 2, plus 2 into x power of 1, y power of 1, degree 2. Whenever we see each term of the equation is having same degree, then we apply homogeneous differential equation concept, that is substituting y equal to vx. Before that let me write down in standard form, that is dy by dx is equals to, send this dx to denominator. Now we have 3y square plus 2xy upon 2xy plus x square. The above equation is a homogeneous differential equation of same degree. Numerator has degree 2, denominator is also having degree 2. So in such cases we apply concept of substitution, that is put y is equals to v into x. Here v is a function of x. Now differentiate this y equal to vx, we'll get dy by dx is equals to v plus x into dv by dx. Now here we have dy by dx, dv by dx. So remove this dy by dx. Now dy by dx from this equation. Here we have 3y square. 3 y value is vx square plus 2x into y value is vx upon 2x into y. 2x y value is vx plus x square is equals to v plus x dv upon dx. Now take x square common from numerator. We have x square into 3v square plus x into x square common. Here we have 2v upon, take x square common from denominator. We have 2 into v is 2v plus x square is common, so we'll get 1. Now these two will get cancelled. Here we have v plus x dv by dx. Now let me write down here. We have 3v square plus 2v upon 2v plus 1. Take this v this side. Here we have minus v is equals to x dv by dx. Now take LCM. Here we have 2v plus 1, 3v square plus 2v minus v into 2v is minus 2v square minus v is equals to, we have x dv by dx. Now 3v square minus 2v square, we have v square, 2v minus v, we have v upon 2v plus 1 is equals to x dv by dx. Now here we have two variables, one is v, other is x. Now convert to variable separable form. Take this x dx to this side, it will become dx upon x. Take this function to that side, it will become 2v plus 1 divided by v square plus v dv. Now here we have x terms together, all v terms together, that is we have separated the two variables, x on one side and v on other side. Now the next step is integrating both sides and adding constant. So here I'll get integration dx upon x is equals to integration 2v plus 1 by v square plus v dv. We add constant, let us add the constant to this side. So here I'll get log c. Now integration of dx by x value is log x. So I'll get log c plus integration dx upon x value is log x. Here integration 2v plus 1 by v square plus v. We know that integration f dash of x by f of x value is log f of x. If I consider the denominator as f of x, if I differentiate this, v square, then we'll get 2v. Derivative of v is 1. So this is f of v. This is f dash of v. So this is in the form of integration f dash of x by f of x, that is log of denominator. So we'll get log of denominator, that is v square plus v. Here log a plus log b value is log ab. So we will get c into x cx log. Here we have v square. This is v square plus v. Now v value, from this value of v can be written as y by x. So this will become y by x square is there, y square x square plus y by x. Now this log and log get cancelled. We have cx is equals to y square plus y by x square. Now if we take LCM, we'll get x square. Here I'll get y square plus x y. If I cross multiply, then I'll get cx cube is equals to y square plus xy. Now this can be written as y square plus xy is equals to cx cube. This is the solution for this question. Let us see the solution. Solve the differential equation x sin y by x dy is equals to y into sin y by x minus x into dx. Given equation is x into sin y by x dy is equals to, we have y sin y by x minus x dx. Now this can be written as dy by dx is equals to, send this dx to denominator. Here we have y sin y by x minus x upon x sin y by x. Here we have y power of 1. Here we have y power 1, x power of 1, x power of 1. That is, each term is having same degree. Here also we have x power of 1. Here also x power of y power of 1, x power of 1. Each term of this equation is having same degree, that is 1. So the above equation is a homogeneous differential equation. Both of them have same order, that is 1. Whenever you see y by x, then mostly those question can be solved by substitution, that is substituting y value as vx. Here v is a function of x. Now differentiate this, we'll get dy by dx is equals to v plus x dv by dx. Now replace this dy by dx from this equation. Here we have y value is vx, so we'll get vx into sin y by x. From this, y by x value is v, so here I'll get sin v minus x upon x into sin y by x value is v. Here we have v plus x dv by dx. Now take x common from numerator and denominator and get cancelled. Here I have v sin v minus 1 upon sin v. This x and this x will get cancelled. Take this v, this side will become minus v is equals to x dv by dx. Now take LCM. We have sin v v sin v minus 1 sin v into v, we'll get v sin v is equals to x dv by dx. Now these two terms will get cancelled. Here we have minus 1 by sin v is equals to x dv by dx. We have two variables, one is v, other is x. Now convert to variable separable form. Here we have v term. So take v terms one side and x terms one side. Take this x by dx here. This will become dx by x is equals to, this will become minus sin v dv. Now we have separated the variables, that is x terms one side, v terms one side. The next step is integrating both sides. Integrating both sides and adding constant to any of these sides. Let me add the constant here. So this will become integration dx upon x. Let me add the constant here, c. Here I have minus integration sin v dv. So this will become c plus integration dx by x value is log x is equals to integration of sine is minus cos. So minus minus will get cancelled. We'll get cos v. Now let me write down this. Cos v is equals to log x plus c. Cos v value. V value is y by x. Y by x is equals to log x plus c. This is the solution. The final solution should contain x and y only. That's why don't take it as a solution. Convert this v in terms of x and y. That is replacing v by y by x. Let us see the solution for this. Solve the differential equation x square minus y square dx plus 2xy dy. So given equation is x square minus y square. This term has degree 2, y square has degree 2 dx plus 2 x power of 1 y power of 1. 1 plus 1 2. So this term is also having degree 2. So when all the terms are having same degree, so that can be solved by homogeneous differential concept. Now get dy by dx. Here we have 2xy dy is equals to, take this term to this side. Here it will become x square minus y square dx. Now send this dx here. This will become dy by dx equal to, multiply the minus sign. We have y square minus x square upon 2xy. Now this is a homogeneous differential equation of same degree. That is, degree is 2 for this. Now put y is equals to vx. Differentiate with respect to x. We'll get dy by dx is equals to v plus x dv by dx. Now replace this dy by dx from here, y square minus x square by 2xy. So y value is vx. Here we have vx square minus x square upon 2x into y. Y value is vx is equals to v plus x dv by dx. Now take x square common from numerator. We have v square minus 1 upon x square common. So here I have 2 into v, 2v. take this v to that side, it will become minus v x dv by dx. Now this will get cancelled. Take LCM, we have 2v, here we have v square minus 1, 2v into v is 2v square minus 2v square is equals to x dv by dx. Now v square minus 2v square is minus v square minus 1 upon 2v is equals to x dv by dx. We have two constant, one is v, other is x. Now convert this to variable separable form. Take this x dx to this side, it will become reverse, that is dx by x, and this term will become 2v upon minus v square minus 1. It will become reverse dv. Now dx by x, take minus common, here I'll have 2v by v square minus, that is v square plus 1 dv. Now all x terms are this side, all v terms are this side. It means that we have separated the variables. Now the next step is integrating on both sides. Adding constant. Let me add the constant here. So here I'll get c plus integration dx by x is equals to minus integration 2v by v square plus 1 dv. Now consider this f of v. If I take derivative of this v square, I'll get 2v. Derivative of 1 is 0, that is f dash of v. It means that we know that integration of f dash of x upon f of x dx value is log of denominator. So here also if I take this as f of v, then v square derivative is 2v, one derivative is 0, so 2v plus 0. So this is in this form. So this will become c plus integration dx by x value is log x is equals to, here I'll get minus, this complete will become log of denominator, that is v square plus 1. Here we have log, so this constant is also log. So let us take log c as a constant. Here also I'll take log c as a constant. So log a plus log b will be log cx. Here this will become log v square plus 1 whole power of minus 1. Since we know that m log a value is log a power of m, this m will become power of this a. So this minus 1 will become power of this v square plus 1. Now this log and this log will get cancelled. We have cx is equals to v square, that is 1 by v square plus 1. Take this v square plus 1, here we have cx is equals to 1. Now this v value from this is y by x. So this will become y by x, that is y square by x square plus 1 into, take this as x, send this c to that side, it will become 1 by c. So here I'll get y square plus x square upon x square into x is equals to 1 by c. Now this x and 1x from this will get cancelled. Here I'll get x square plus y square into this x into c, that is x by c. So this can be written as x square plus y square is equals to, take this 1 by c as another constant a into x, where a value is 1 by c. C is a constant and a is also a constant. So this is the solution for this question. Let us see the next question. Solve the differential equation 1 plus e power of x by y dx plus e power of x by y into 1 minus x by y dy equal to 0. Here we have x by y, x by y, x by y. Whenever we see the ratio of x by y or y by x, we usually solve by homogeneous differential equation method. So let us see here. Given equation we have 1 plus e power of x by y into dx plus e power of x by y into 1 minus x by y dy equal to 0. Now here we have 1 plus e power of x by y dx is equals to, send this term to that side. Here I'll get minus e power of minus x by y into 1 minus x by y dy. Now send this dy to this side. Here I'll get dx by dy is equals to, here we have minus e power of x by y into 1 minus x by y upon, take this to the denominator, we have 1 plus e power of x by y. We got dx by dy instead of dy by dx, since the given equation has x by y, x by y, x by y everywhere. That's why we have taken dx by dy. Now here we have x power of 1, y power of 1, that is degree is 1. Here we have x power 1, y power of 1, degree is 1. So everywhere the degree is 1. It means that this is a homogeneous differential equation of same degree, that is 1. Now for this we made substitution. Here we have x, so take x is equals to v into y, not v equal to yx. Here v is a function of y. Differentiate above function with respect to y, not with respect to x. Then here I'll have dx by dy is equals to, I'll get v plus d, v plus y dv by dy. Now dx by dy value from this, here I have minus e power of minus x by y. From this the value of x by y value is v. So here I'll get e power of v into 1 minus x by y value is v upon 1 plus e power of v is equals to v plus y into dv by dy. Now multiply this. Here I have e into 1 is e power of v, minus into minus plus e power of v into v by 1 plus e power of v. Take this, here we have minus v is equals to y dv by dy. Taking LCM, we have 1 plus e power of v. Here I have e power of v plus e power of v into v. V into 1 is minus v. V into e power of v is minus e power of v into v is equals to y dv by dy. Now here These two terms will get cancelled. Now we have e power of minus v upon 1 plus e power of v is equals to y dv by dy. We have two variables, one is y, other is v. So let us convert this into variable separable form. Take this y by dy to this side, so this will become dy by y. Send this term to that side, it will become reciprocal, that is 1 plus e power of v upon e power of minus v dv. Now take minus common, dy by y is equals to take minus common. Here I have 1 plus e power of v upon e power of v plus v dv. Here we have y terms one side, v terms one side, that is we have separated the variables. Now the next step is integrating. Integrating both sides and adding constant. So here I'll add constant c plus integration dy by y is equals to, minus sign is there, minus integration, let me take it as e power of v plus 1 by e power of v plus v dv. Now this will become c plus integration dy by y value is log y. Now if I take this denominator as f of v, and if I differentiate, e power of v derivative is e power of v, derivative of v with respect to v value is 1. So here we have f of v, in numerator we have f dash of v. We know that integration f dash of x upon f of x dx value is always log of denominator. So this will become minus log, denominator is e power of v plus v. Now here we have log term, so this constant must be a log constant. So I should take log c here, log a plus log b, value is log ab, log c into y, log cy is equals to, this will become log e power of v plus v whole power of minus 1, since m log a value is log a power of m will become power of a. So here this log and this log will get cancelled. Here I have cy is equals to 1 upon, this inverse will become 1 by e power of v plus v. Now cross multiply, here I'll get e power of v plus v into cy is equals to 1. Now this v value is x by y plus x by y. Here I have y into y, take this c to that side, it will become 1 by c. So finally the answer is y into e power of x by y plus, here if I multiply y and this y will get cancelled, will get x is equals to 1 by c is a constant. So let us take it as some other constant a. So a, where a value is 1 by c. This is the solution for this question.